Alright, so hello and welcome. Howdy. I'm gonna whisper, just keep my voice, save my voice a bit, preserve my voice. Welcome, 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 welcome. So, we are going to take a look at another problem on LeetCode called Minesweeper. Let's get right into it. So here we are. Let's see how we do. So this is going to be let's play the Minesweeper game, Wikipedia online game. I actually have been playing a lot of Minesweeper lately. It's a lot of fun. I think literally because I saw this problem the other day and I was like, hey, I want to play this game. So I went and played it. It's a lot of fun. Given an M by N character matrix board representing the game board where M represents an unrevealed mine, E represents an unrevealed empty square, B represents a revealed blank square that has no adjacent mines, i.e. above, below, left, right, and all four diagonals. Digit 1 to 8 represents how many mines are adjacent to this revealed square, and X represents a revealed mine. You are also given an integer array click, where click equals click sub R, click sub C, represents the next click position among all the unrevealed squares M or E. Turn the board after revealing this position according to the following rules. If a mine M is revealed and the game is over, you should change it to M, to X. If an empty square E with no adjacent mines is revealed, then change it to a revealed blank B, and all of its adjacent unrevealed squares should be revealed recursively. So that's interesting. So this is basically a flood fill. If an empty square E with at least one adjacent mine is revealed, then change it to a digit 1 through 8, representing the number of adjacent mines. Turn the board when no more squares will be revealed. And what do they mean by adjacent? Okay, by adjacent they do mean all 8 possible positions. Okay, so we click here, everything gets revealed. Revealed line X, digit 1 through 8, revealed blank square, unrevealed empty square, unrevealed line. So it's basically going to be one tick of Minesweeper we're going to program here. Sweet. Sweet. So we are actually going to modify the board though. Well, we can return a copy of the board. That's fine. Yeah, so I've actually solved this before in the past. Yeah, and the vector is just a row column. So we'll say so you have a row column, and we can make this const reference. Doesn't need to be new integers. So we're going to say auto. So we're going to say make a copy of the board. So we'll say vector of vectors of characters, new board. It's going to be equal to board. And now, so we'll use the copy assignment operator. Let me just return the new board and see, make sure this works the way we expect. I think it does, but we'll just double check. Four minutes in, okay. Alright, so now a couple of things here. I mean, a few things to note. We can pre-process the board and just assign to each position like how many mines are nearby. I think that's a good idea to do it that way. And that way we only need to do that once, so won't call this a new board. We'll say there's a new board, but we're also going to make it another board, and we're going to use a tuple characters, and or actually really we could just say, it doesn't even need to be a tuple, it could just be the position itself, so we could say ints, and we're going to say and we could just say like board mine number, yeah, something like that, board mine number, call it that, and then this could just be number of rows would be board size, number of columns would be columns, number of columns, and I guess we already know that there's at least one M and N is they're both M and N or at least one, so we won't run into issues doing this. Okay. So now we can set this up as the number of rows, and then each of these are going to be vectors of ints, and these will be the number of columns. That'll be initially 0. The number of mines, rounding each board position. Save this value. Save these values. Alright, so we're going to have auto mine count. This isn't going to be the fastest approach, but it'll be relatively fast. Yeah, this is fine. The mine count is going to be a subroutine. We're going to have another subroutine, so we're going to say inbounds it's going to take const int reference row, reference column, and say return row is greater than or equal to 0, and row is less than the number of rows, and column is greater than or equal to 0, and column is less than or equal to less than the number of columns. That should be like an inline function, I suppose. I don't know if you can inline lambda expressions. That would be interesting. I don't know that you can. I don't think you can. Mine count would be row, column. This is going to be, we're going to take inbounds. Oh, I did that wrong. This is also n rows and columns. Right. Now we have inbounds. So we say the directions as well. We can use. So this is going to be make tuples. We're going to do it this way. And we have 8 different directions. One, 2, 3, 4, 5, 6, 7, 8. We're going to say int. Now we're going to pick each direction. So we have -1, 0, -1, -1, -1, -1, 0, -1, 1, 0, negative 1, 0, 1. We don't have 0, 0, and then we have 1, negative 1, 1, 0, and 1, 1. And presumably we can find, well, actually we could do it this way. We don't need to use auto here. Okay. Right, do it this way, all the different directions. And now we can say for const auto dr dc of and I think we make these are all references of directions. Say if so we'll say in constant reference, we'll say A and B, or new row is row plus dr, and new column equals column plus dc if in bounds of n, r, and c. And we have a mine count we're going to return. So if we're in bounds, and we're going to update ret. Probably, this could actually be a subroutine. This could be this doesn't need to be a raw loop as well, which is interesting. So we can actually call it a temporary function, a lambda expression inside of a lambda expression, if you can imagine. Yeah. We could say actually you could do const standard tuple of ints x, and you say basically drdc I'm not sure if I prefer this better. I think I like the raw loop a little bit better, but you're actually it's gonna get an accumulate function. So this is going to be over directions.begin, directions.end. So for each direction, we're going to call temp and 0. Let me see here. Why is this struggling so much? How are we doing on time? 14 minutes in, 15 minutes in, okay. So the binary operator should take type 1, type 2, okay. And return type. Type 1, type 2, I think type 1 is, total. And we say, return, basically total plus this converted to an integer in inbounds and RNC, and the other one, which is oh yeah, well, this is temp. It should be 0 temp. What we're going to do is say and we have the board here. So we're going to say board of NR and C is equal to mine, which is M, unrevealed mine. There we go. Right. So the number of unrevealed mines. So we can accumulate and return this value to get our mine count. And now we can say, so we have our directions, we have our inbounds, mine count, and now we're going to say for int I equals row, or row equals 0. Row is less than number of rows. Increment the row. Int column equals 0. Column is less than the number of columns. Increment the column. And we're going to say, so we're going to say the board mine number of row column is going to be equal to the mine count of the row and the column. So now we update all of the spots in the board. So we have the board mine number updated, and that's pretty efficient, or not efficient, that should give us what we want. And now we can say DFS fill routine to reveal the board state. Reveal the board after a click. So we'll say DFS. And we're going to say our DFS, so we DFS on the new board and return the new board. I think that's what we're going to do. And we'll make it recursive, it's fine. We use R and C instead of row and column as well. Yeah, so base case if not inbounds. But if we are inbounds, base cases will say if board, our new board, we're going to say new board of, and this doesn't have to be the board, it could be the new board. Well, it could be either one really, but we're going to use the new board. So the new board of RC is, if the new board of the RC is equal to, it could be a few different characters. If, so I'll give the rules. If a mine is revealed, so if it's M, we say game ends, game over. We're going to return, we're going to change new board of RC equals E Now you need to be careful to X. So, well, actually, we don't need to do this check here. Yeah, row column click. Assuming this click is not off the board, I don't think it can be. Yeah, we know these aren't going to be. We can do that outside of our DFS. Alright, so if our new board is E, well, let's say, what are the other cases where it ends, where it stops? I think they're all E. So it's either blank or there are mines. If it's blank, we keep going, otherwise, so basically if it's 0 or not. So we're going to say new board. So we want the other part, which is the board mine number. Just put that another line. If board mine number of our C is greater than 0, then we return. We don't continue. And we say new board of our C is equal to, or set to, its mine number. Right? Yeah, and we only count the mines around. So, a few things here. Some base cases, right? So if new board of our C equals M, skip any mines as we performed. The direct check. Clicking on mine at the top. Calling this routine subroutine. So I skip any M's. If board mine number is greater than 0. So if the new board is, so I guess it depends if the new board, it's either a mine or it's empty. Initially, assuming it's not a mine, then it must be empty. If it's empty, we have to check the board number. The board number is non-zero, then we update it. So we don't need to check here. Now finally, from here, in each direction. Alright, so now we recurse in each direction. So we need the directions here. f of row plus dir and column plus dc and f again. And that's it. I think that's all we need to do. Something like this. How are we doing on time? This compiler, okay. 25 minutes. 24. Ah, very close. Almost got it. Almost got everything. Almost got everything. I was close. I was close. Missed on multiple cases though. I like how I have double a lambda expression within my lambda expression. Oh yes. Lambdas abound. Imbalance cannot be implicitly captured. Oh, okay. Fair enough. That's interesting. What about new board? I guess new board can't be implicitly captured either. Let's see. Oh, that's a mistake also. Let's see how we do here. Runtime error. Nice. Okay. Of course. Of course. Nice. What happened, I wonder? Excuse me. Alright. Perfect. What happened? Where did we get a deadly signal from? I mean, I don't know. Let's see. Was it the flood fell? This question is kind of a gimme, but I programmed it incorrectly somehow. That's my own fault. It's my own fault. It seems that it was the flood fell. Of course. Now my question is why? Why is the flood fell? I see. I know the problem. It's very subtle. Because we have to mark the ones we've already visited. We should set this to B. So, hold on a second. So, what I need to do is set this to. I made a mistake. Yeah. positions that I've already written to. So it's anything other than an E. So it could be a B or a digit. We don't, excuse me. If it's a B or a digit, then we want to skip it, or an M, any of those things. In fact, that would be, this would be redundant here. So we skip anything we've already written to. So at this point we know that has to be an E, so we don't have to check that here. So if it's greater than 0 at this point, we can set this to the new board is B, and now recurse. Reveal blank state. Yeah. Something like that. Something like that. Still get a runtime error. Nice. Okay. Oh, that's why. That's very subtle too. That's subtle, but it's easy to miss that one. And we're wrong. Okay. Now, what's going on? These should be converted from integers to characters as well. That's another mistake. So it's going to be 0 plus. Yeah, convert that back to a character. There we go. Right, I see the issue. Yeah, those are non-printable characters. If you convert the integer to its digit, representative character. Yeah, that's kind of a subtle thing. You gotta make sure you have the right character representation, the right ASCII character. Alright, so that took some time. I think this is correct. I think we probably would want to run this in a bunch of test cases. So, can we, yeah, let's use example test cases and run, see how we do. Wrong, really? Oh no. No kidding. Oh, that's a nuisance. Which one? Oh, I see. I was going to say we need to test the failure case. Oh, I didn't update the M, that's why. It's kind of subtle. Or not subtle, yeah, not subtle, yeah, it's subtle. Yeah, I would say so. It's easy to miss. Maybe not subtle, but easy to miss. It's a very minor thing. Slight thing. Yeah, alright. I think we just go for it. I don't know. I probably should test some things first. Really should have just tested some things. It's very unlikely to get it right in the first shot. But we did get it right in the first shot, so that's pretty good. Yeah, probably not the fastest way to do this though. Because you could probably perform the mine count, you know, updating the mine board member number. You probably could do that more efficiently. You know what you could do? You could take each mine and update each area around the mine. That might be better. So instead of going from the perspective of every single spot and checking all 8 around it, might be more efficient to actually go from so you can calculate the mine count in a different way. I think that's more efficient because we're getting kind of a low score. Pretty good that we solved it though. That's not too bad. About 35 minutes, 40 minutes or so. But let's see if we can do it a different way. So the mine count we can do is we can say instead of a mine count, we can say update mines, which is a little bit better. Slightly different routine, but if you don't have a lot of mines, a little bit better. So you can say update mines, right? And we'll say inbounds, directions, new board, row, column, right equals 0, so we're not going to do that anymore. We're going to say, put this on a new line, we're going to say, new board, we're going to say, this board mine number, right? And what we're going to do is take, for each direction, it's a very similar kind of routine here. We're going to say update mines, we're going to say for each direction. So the if will be, I presume, yeah, or update mine count, we'll say, or update surrounding, update surrounding mine count. We'll call it that, the update the surrounding mine count. So in all the directions that are inbounds around this position, we're gonna update, we're gonna add 1. So we're gonna say if inbounds of row plus dr and column plus dcolumn. New row is row plus drow, and new column is column plus dcolumn. And we say if inbounds of new row, new column. Then we're going to say board mine number of new row, new column, plus plus. And we do this, yeah, do this routine. So we update our surrounding mine count. Which actually this really should be in line, I think. They should really just be in line. I can put that here. This is a little bit more efficient, in my opinion. And we just have an if statement inside. Say if new board of row column is equal to a mine. So we could say update the mine count by considering each mine individually. So this might be a little bit more efficient, I think, than this other approach. Yeah, we could still perform. I think it's better to perform this routine this way. Yeah, it's not really accumulating anymore. Quite the same as accumulating. So if it's a mine, then we're going to look in each direction, check if we're inbounds in that direction. If we are, then we're going to update the board number by 1. So this should give us the same result, but it might be a little bit faster. Let's see how we do. Okay, it's actually slower, this one, it seems. I wasn't expecting that. I actually thought this one was faster. We'll do one more. No, it seems to be slower. That's interesting. So this is a little bit more concise, I think, to do it this way. But alternatively, you can write a mine count routine as well as a board mine number. I don't know. Part of me thinks that this is more efficient. I think this might not be as efficient, and the reason is that in this case above, we check each position individually, but that means that each mine is going to be touched. Yeah, I don't know. I guess not that much. Like, this is going to visit every position and then perform 8 checks on every position, right? This one, on the other hand, is going to take a look at every position, but only on the position that mines or 8 checks going to be performed. So I think for sparse mine graphs that don't have a lot of mines, this is more efficient. I think so. I think this is not always more efficient. I'm actually kind of wondering why this one is less efficient, why this one's more efficient than the other. Oh, it's not. Okay. So the second one is more efficient. All right. It seems kind of random, but that's what I was just looking at. Like, I think, yeah, it's kind of random what you get. I think the second one is more efficient because it's 8 times the number of mines, which is not necessarily the whole picture, whereas the first one is always 8 times every position. I also think this one's a little bit easier to write. Yeah, we're going to go back to what we had. I think the second one is better. I don't really know of a faster way to do this, quite frankly. Just to be blunt. Maybe you could do a binary search to find each mine. That could be made faster. Yeah, you could do it faster that way. Instead of checking every single position for every mine, you could binary search across the rows and the columns to find the mines. That's a lot faster than doing a linear search for the mines. Yeah, I think this is the best. This is a lot better to do it mine by mine. Yeah, because you can actually optimize a little bit by so if you took 50 and you take log base 2 of 50, yeah, you can go 10 times faster. So yeah, we could probably get 100% on this one if we performed a binary search for the mines. Well, I don't know if you can do a binary search to take that back, because the mines themselves are they're not in sorted order. I take that back. That's not true. That's not true at all. No, never mind. You can't go much faster than this. I take it back. I don't know how to go faster. There might be a faster way, but I don't know it. Maybe what you ought to do is interweave in the flood fill. Yeah, in the flood fill, check to see if there are any mines, and maybe update. Maybe after this recursion, you can recurse on each side. I guess something like that. Recurse in all directions, and then update with the value depending on what you have. So maybe here you can include the check and increment a certain number, and then at the number at the end here, you check that number. If it's 0, keep it B. If it's not 0, then update it with a digit. And obviously, if you see any mines, you just skip them. Anything that's not an E, you just skip it. But I guess you just have to check if both of it's inbounds, and if it's if these two values, these are inbounds, and if they're not inbounds, then you don't even continue. So you don't have to do the inbounds check here. So you can do that too. That might be a little bit more efficient. Also, counting the mines nearby but take this subroutine, mine count subroutine, and rewrite this slightly. And so at each position, or even kind of inline that here. So at the same time, you're both iterating on, you know, each position, and you're also counting the number of mines. So if it's a mine, you don't continue here. But if it's not a mine, you would continue. And then the inbounds check you would do here too. And then also you count the number of mines and modify down here after the recursion. You can do it that way too. And then you don't need a board mine number. Yeah, you still need directions though. And also we don't need to actually copy this new board, by the way. We could just modify the board itself and return that. That would save a bit of time too. So there's at least two different ways we can approach this. I think that would be slightly faster. One is we don't actually build the board mine number. We can do that within the flood fill, and then also we don't need to copy this board. We can modify this in place and return it. There are both of those options. I think, in my opinion, it's actually kind of, I don't know. The general style, after my comments, I like to have a space. I'm just wondering though if references should have a space, because I like to put the space between these two here. Yeah, I think that's fine. I think it's fine. All right, so I think there's at least two optimizations I can think of that would probably push us into 100%. How are we doing? 47 minutes. All right, we can stop here. There's at least two optimizations I can think of that would probably put us at 100%. But this is pretty good as it is. We don't need to go get too crazy here. This, yeah, there's some options. All right, let's get on to it. Let's stop here. So thank you for watching. I think what I'm going to do is take a break here for some time. I don't know what I want to do exactly. I think I'll just end it here. So thanks for watching. I'll talk to you soon. Have a good rest of your day. I may or may not keep going. I don't know.